How will different light colors impact oxygen production from spinach discs?
This is the introduction. So photosynthesis is the process where plants convert light energy into chemical energy, which they release oxygen as a byproduct. And so there are different types of light, and they may have different effects on oxygen in each leaf. So using spinach leaves, soda water, and different lights, this experiment aims to find which light is most effective for photosynthesis in spinach leaves. And we use spinach leaves as the model organism because they're an easy test for oxygen production.
Our research question was what color light is best for photosynthesis? Our null hypothesis was the different colored lights will have no significant effect on the amount of spinach discs that float to the top. Our alternative hypothesis was the different colored lights will have a significant effect on the amount of spinach discs that float to the top. And then our prediction was the white light will cause the most spinach discs to float to the top, and the no light will have the least amount of discs that float to the top.
So for the experimental design, the experiment needed 12 cups of soda water, and they were separated into groups of three with different types of light. We also needed 12 sets of 10 discs of spinach leaves. And using a syringe, the oxygen was removed from the water and leaf mixture to get the spinach leaves to sink to the bottom. And then the sunken leaves were placed in the 12 separate cups where we put them under different kind of lights to see um, how the oxygen got back into the cups. For the data collection, we set the cups under the appropriate light, with one set being under a shoebox as a negative control. The number of leaf disc floating was observed every 3 minutes over a 21-minute span. And then the data was placed into an Excel spreadsheet to generate a line graph. The number of each leaf disc was examined with trends and standard error represented on the line graph.
So this was the data that we collected, and I'll talk about it more in the next slide. The trends that we saw were the full spectrum light had a greater mean and standard error, and there was no change in the no light group and the blue light group. For our full spectrum light, the mean was 0.561 with a standard error of 0.45 and a slope of 0.03. For the no light group, the mean was 0 with a standard error also being 0 and a slope of 0. For the yellow light group, the mean was 0.0317 with a standard error of 0.25 and a slope of 0.03. And then for the blue light group, a mean of 0, standard error of 0, and then a slope of 0. For discussion, the oh my God. The trend supported our null hypothesis of the lights not having a significant effect on how many disks float to the top. We failed to reject the null, and we rejected the alternative hypothesis. The white light most likely worked since the light was brighter than the rest of the other lights. And then for our limitations, we mixed our cups up with other groups' cups. We were not able to get all the discs to float to the bottom of the syringe during the during us trying to get the oxygen out of the water and the spinach. Not putting the cups under the shoebox as soon as we were taking them out of the as soon as we were taking the disc out of the syringe, and this relates to the real world since it shows how much which form of light produces more oxygen, and our question is how would the results differ if we use the green light other than the other lights. And then these were our contributions.